Okay, now let's talk about anti-aromatic rings. So anti-aromatic rings have one of the same characteristics as aromatic rings, but like I said in my earlier video, they're significantly unstabilized. They're like the opposite of stable. Nothing wants to be in an anti-aromatic ring. So what aromatic rings and anti-aromatic rings have in common is they have a ring of p orbitals that's unbroken. So you can see each of these is sp2 hybridized. So there's a p orbital at each of the spots on this 8-membered ring. But the number of electrons is really what sets them apart. They have 4 in pi electrons. So if there are 0, 4, 8, or 16 pi electrons present, then it's going to be anti-aromatic. So again, pi electrons come from double bonds or carbanions. We have 2, 4, 6, 8 here. So it looks like that is 4 times 2. So that is in the 4 in category of pi electrons. So this would be anti-aromatic. Now, to kind of bring it all together, you should be able to look at these molecules and tell me if they're aromatic, anti-aromatic, or non-aromatic based on the videos I've shown you today. Now, if you can't, that's okay. We'll be going over it in class. But if you can, you're in awesome shape. You're ahead of the curve. You're ready to go for this unit coming up. Okay, spoiler alert, I'm about to post the answers. So if you don't want to know, pause the video. I'm going to put them up and pause to check to see if you're right. I'm going to have the number of pi electrons for each one too, so check yourself on that to see if you calculated those up right. Okay, here are the answers. 6 pi electrons, 2 pi electrons, so both of these are aromatic. This carbocation is kind of tricky, but that is sp2 hybridized. This is non-aromatic because there's two sp3 hybridized, and then both of these have a continuous pi orbital chain, but also both of those have 4 in pi electrons, so 4 and 8, so those are both anti. I hope that was helpful, and reach out if you have any other questions on aromatic, anti-aromatic, or non-aromatic rings.